The autoregressive part of ARIMAX models expresses the future time series values as a function of past time series values. We fit a linear regression whose inputs are the previous time series values. We must make a choice on how far back to go when fitting the linear regression, and this choice is motivated by how much of the past we want to use to determine future time series values. This choice is important for model performance. If we choose too many past points to include, we might overfit the training data by adding too many free parameters into the model. If we choose too narrow of a window in the past, we might miss the signal and build a model with poor performance. Although we could stop here and fit autoregressive coefficients using least squares estimation, we choose to include moving average terms in the regression as well. Moving average models predict future values as a function of errors from previous time points. Rather than the future depending on past values, it depends on the errors made by the model at previous time points. These errors are often called shocks because they represent differences between the model expectations and reality. The final component of a ARIMAX model is the effect of exogenous variables, which are used as inputs to the linear regression formula that we've been constructing. These external variables must be known at each time point for them to be useful in predicting time series. The autoregressive terms and the moving average terms are added together with the exogenous variable terms in a combined ARIMAX model. We construct a multiple linear regression where the future value we're trying to predict, yt, depends on past values of y, the autoregressive part, past errors made by the regression formula, the moving average part, and external variables measured in advance, the exogenous variable part. The overall model is fit to find the optimal values for each of the weight parameters introduced in each component. The automatic forecasting CAS action will fit an ARIMA model with no exogenous variables and compare it to an ARIMAX model with exogenous variables included, if there are exogenous variables in the data. It will also compare these models to an exponential smoothing model. The model with the best root mean squared error will be selected as the automatic forecast.